For Module 16, in the reading, questions 16 through 24, they're all related, and they're all about solving the pH of a buffer. And the buffer that we have is acetic acid and sodium acetate buffer. And so on the onset, they tell us we've got this 0.6 molar acetic acid and 0.4 molar sodium acetate buffer. And that's in 90 milliliters. And then to that buffer, we're going to add 10 milliliters of 0.1 molar HCl. So the first few questions are relatively straightforward questions. They want you to first find the initial pH of this buffer. And for that, we need to have the Ka of acetic acid. The Ka of acetic acid is 1.8 times 10 to the minus 5. So for question 16, all we're asked to do is to find the pH. We're going to use the Henderson-Hasselbach equation. pH equals the pKa plus the log of the concentration of my base over the concentration of my acid. So the pH of this buffer before I add the HCl to it, it's going to be the negative log of 1.8 times 10 to the minus 5 plus the log of my base concentration, 0.4, over my acid concentration, 0.6. My initial pH is 4.57. Ultimately, we're tasked to find our final pH after adding HCl. HCl is a strong acid, so we can guess that our final pH should be below 4.57. It should be more acidic because we're adding an acid to this buffer. The buffer that's composed of acetic acid and sodium acetate, once we add the HCl, it's going to react with the conjugate base. It's going to react with the sodium acetate. And that's question 17. So we're going to react with the acetate ion when we add this to the buffer. Next, we're asked to find out how many moles of each of these we're adding. And for that, we need to do some M1V1 equals M2V2 calculations. My initial molarity times my initial volume equals my new molarity at my new volume. And we're asked to do this for all species in the reaction. So we're asked to do this for acetic acid, we're asked to do this for the sodium acetate, and we're asked to do this for HCl. So for the acetic acid, I start off with a 0.6 molar, and I have 90 milliliters of that solution. I need to find my new concentration when I have 100 milliliters of solution, because remember, we're adding together the 90 milliliters of my buffer with the 10 milliliters of the strong acid. So my final volume is 100 milliliters. Same process for the acetate, 0.4 molar, and I had 90 milliliters of that at the start. I need to find my new concentration when I have 100 milliliters of that. And for the HCl, I've got 0.1 molar HCl. I only had 10 milliliters of HCl, but I can still find my final concentration once I dilute it to 100 milliliters. So my final concentration in molarity is 0.54 molar of the acetic acid, 0.36 molar of the sodium acetate, and 0.01 molar of the HCl. So for questions 18, 19, and 20, they ask us for moles. Molarity is what we have right now. We don't have moles, but we can find moles because molarity, right? Molarity is simply moles per liter. So to find moles, we can simply multiply by the volume that we have in liters. So 0.1 liter and we see that we've got 0.054 moles of acetic acid, 0.036 moles of sodium acetate, and 0.001 moles of HCl. To answer questions 18, 19, and 20. After we add the HCl, right, HCl is my limiting reagent, so after I add the HCl, it will all be consumed. So we're going to use all of the HCl during the course of this reaction. Now if we take a look and figure out how these concentrations are going to change during the course of the reaction, I would set up in the same way we did in class. We have 0.054 moles of acetic acid, and we have 0.036 moles of the acetate, the conjugate base. And then to that, we're going to add the 0.001 moles of a strong acid HCl. The acid HCl is going to react with the acetate, so we're going to expect to see this concentration go down, and the product of that reaction is more acetic acid, so that concentration will go up by how much? 0.001 moles. So after the reaction takes place, we're going to see this concentration go up a little bit. The number of moles of acetic acid is going to go up a little bit, and the number of moles of the acetate will go down. So our new number of moles of acetic acid, 0.055, just adding in that one more mole. And for the acetate, 0.035 moles of the acetate. So after the reaction for question 22 and 23, moles of acetic acid after the reaction, 0.055, and then moles of acetate after the reaction, 0.035. Now we can find the concentration of acetic acid, right? The concentration of acetic acid can be found by, well, we have 0.055 moles, and we have that in a 100 milliliter solution, so 0.1 liters. Right, at the end of the reaction, we're going to have 0.55 molar acetic acid, and we're going to have 0.35 molar acetate. So after this reaction, we can run the Henderson-Hasselbach equation one more time to find our new pH. Right, pH equals the negative log of my Ka, 1.8 times 10 to the minus 5, plus the log of my base concentration. My new base concentration is 0.35 over my acid concentration, 0.55. Right, the new pH of this buffer after I add the HCl drops down to about 4.55. And we made that guess at the start because our initial pH was 4.57. To that, we added the strong acid HCl, so we guessed that the final pH would be less than the initial pH. And that's what we see here.